Most web APIs built with ASP.NET Core are using MVC. It's the most mature way to build web APIs today, although minimal APIs are likely to become the standard at some point in the future. ASP.NET Core MVC has a lot of great features that aid in producing high-quality web APIs. I'm going to list many of them here quickly, and then we'll drill into a few of them. First, if you're building web APIs, you should almost certainly be decorating your controllers with the API controller attribute. It adds a couple of nice features to all of your APIs. Specifically, it enforces attribute routing, which is recommended for all API endpoints. If you mark your controller with API controller, it will ensure that any endpoint that you have there, any action method, utilizes attribute routing. Model binding, and especially model validation, are two great features of ASP.NET Core MVC. And if you use API controller, you get model validation with 400 bad request responses being returned automatically. This can dramatically reduce how much work you need to do in each of your action methods. Another best practice related to MVC is to reduce controller size. There are several advantages and ways to approach this, which we'll cover shortly. ASP.NET Core MVC supports a variety of filters. If you want a consistent API, you should use filters to create that consistency. And of course, ASP.NET Core APIs support async, which should be your default for most of your endpoints. Only switch to using non-async action methods if your endpoint isn't doing anything asynchronous, which should be pretty rare if it's talking to any external services or data. But wait, there's more. You also get support for response caching, which adds standard HTTP headers to support client and proxy caching of your server's responses. You can also add response compression, which can provide a performance boost with minimal configuration needed for large text-based responses. Of course, if your API is going to have unknown clients, you may want to support a variety of different formats. Using content negotiation, you can let clients choose the format they wish to use using an accept header on their requests. You'll also want to specify a default exception handler and make sure that you have different experiences for developer and production environments. You get access to the action result of T, which we covered earlier in this course, and finally you benefit from all the functionality in the controller base class, and you should also consider using your own base class if you can. You want to try and keep your controllers under control. Smaller controllers are easier to manage and maintain. They're less likely to have merge conflicts, and having several small controllers is more amenable to team-based development with simultaneous workflows than a single giant controller. One way to keep controller size under control is to minimize the logic inside action methods. Most controller actions should have no conditionals in them. Any common checks that you perform in multiple different actions should probably use filters that are applied to those controllers or actions where that behavior is needed. Action methods shouldn't have business logic or data access logic in them. If you follow these rules, you'll find that there's not much else to do conditionally within an action method. Your action methods should also avoid using try-catch statements, especially for flow control. Try-catch statements are just another kind of conditional operation, and using exceptions combined with try-catch to perform logic such as whether to return a not found or a bad request response is an anti-pattern. A better approach is to return some kind of a result abstraction from services that may need to return non-exceptional but non-successful responses. By following this guidance, you can avoid large controllers which tend to lack cohesion, tend to grow over time, and tend to have more total dependencies and tight coupling. Keeping your controllers under control helps you avoid all these issues. Now let's talk about filters and a related piece, middleware. If you look at your APIs and the individual endpoints or action methods, and you see a lot of the same kind of code, chances are you can refactor some or all of that logic into filters. If you have logic that doesn't rely on MVC types or features, like model binding, you may be able to use lower-level middleware instead of using a filter. You should think of filters and middleware as your go-to feature for applying consistent policies to your web APIs. Don't rely on developers remembering to perform certain actions in code. Instead, make common cross-cutting concerns part of the application as a whole by using these tools and techniques. A couple of common filter and middleware use cases are for model validation, which API Controller provides for free, exception middleware with logging, and adding analytics. We'll also take a look at some other filters as we go through the other features that you should be using. Async and await should be your default. Any API endpoint making out-of-process calls should be async. It could be talking to a database, another API, the file system. It doesn't matter. There are async libraries to work with all of these resources. It should be very rare that you have useful API endpoints that aren't async and thus do not return a task of something. You can use the response cache attribute to add cache headers to your resources. These headers are used by clients and intermediate proxy servers to determine whether and how they should cache the responses. Note that these responses are not stored on the web server by default. The only thing the basic response cache attribute does is add these caching headers, which abide by RFC 7234 on HTTP caching. However, if you do want to store responses in server memory in order to get a performance boost by not having to make database calls as often, you can also add response caching middleware. This can be combined with the response cache attribute. If you do, you'll probably want to make sure that you use the vary_by_param option to ensure that you don't return the wrong response to requests that use different query string parameters. For example, if you're using query strings for paging, you don't want to cache page 1, and then when someone asks for page 2 using a different query string variable, you show them the cached version of page 1 again. The middleware stores these responses in server memory, so this may not be a good approach if you have a multi-server deployment environment. The response cache attribute can be added to any controller action to enable ASP.NET Core to add response headers with cache information. In this case, the duration is set to 10 and the location to any, resulting in a header that looks like this, specifying cache control of public with a max age of 10, and this is 10 seconds. Clients and intermediate proxies can use this header to determine whether a response can or should be cached and for how long. You should consider whether and how your API will leverage response compression. By default, you should rely on your web server implementation for compression, since these will generally be faster than compression you can perform using middleware. IIS and IIS Express support compression by default. If you are going to implement compression yourself, you need to avoid compressing small responses, since the overhead to perform that compression makes it not worthwhile, and in fact some algorithms may result in compressed results that are larger than the original value. Generally, you want to avoid compressing responses that are less than 1,000 bytes to begin with. Clients must inform the server of the kind of encodings they support using an accept encoding header. The server should respect these encodings and should specify the encoding used in a content encoding header in its response. Also, there are known security issues with using compression over HTTPS. See the docs link below for details and how to mitigate this risk. To configure response compression, add it to your app's services. You can configure options and add additional providers if needed. Then, after the app is built, add the middleware to your request pipeline, as shown here. To configure content negotiation, if you expect to have clients that will expect a different content format, like XML, you'll need to make a couple of small changes to how you configure MVC. First, you should specify the accept header should be respected, so that when a request specifies it wants a different format, that request will be heeded. And second, you need to add another format beyond the default JSON formatter. This code shown here adds support for XML serializer formatters. With these changes in place, and assuming that your model types are serializable, passing in an accept header with a value of application/XML, as shown, should result in the response being formatted as XML, as you can see in this example. Unchecking the checkbox next to the header in Postman removes that header, and thus results in the typical default behavior of returning the response formatted in JSON. When something goes wrong in your Web API application, you want to make sure the client is informed appropriately. Usually, in production, you will want to expose less detailed information than in development. You can configure explicit exception handler endpoints for development and production environments to ensure that your API uses a consistent approach to error handling. For the production environment, the default error handler should avoid providing any details. You just need to define its route and tell Swagger not to include it as part of the set of endpoints to be documented. Using the API Explorer settings ignore API equals true attribute handles this for you. The problem helper method does all the work of returning the problem that was resolved to the user without any additional details. Hitting an endpoint that throws an exception, this production error handler returns a response that looks like this one. Ideally, you would log the trace ID so that if a client were to report this as a bug and include that trace information, you could identify the request in your logs. In development environments, you'll probably want more details. You can use the same approach though, but with a different endpoint, like the one shown here. In this case, the code first verifies that it is in fact running in a development environment, returning not found otherwise. This prevents anyone from hitting this endpoint while you're in production. Then, the action method uses the built-in iException handler feature to get the exception stack trace and exception message, and this is returned as a problem object result. Hitting that same endpoint, but now in a development environment, results in the response shown here. I've cut off some of the stack trace, but you get the idea. The title has the exception message, while the detail has the stack trace. This can make it much quicker and easier for developers to determine the root cause of a problem, but obviously should not be exposed publicly.